in tech. It's good to see such passion and enthusiasm. My name is Ayush. I'm the co-founder and CTO of Portkey. Anyone here have heard of Portkey before? Good. New audience for me then. Awesome. So this talk is not about Portkey. We're going to talk about AI Gateway as a pattern. What essentially is AI Gateway? Why do you need an AI Gateway? And how do you build an AI gateway which scales for billions of requests? And that's the topic, which is how do you build a billion scale AI gateway? A little bit of this thing about me. Before I started Portkey, I've been building generative AI applications for the last 3.5 years. From before GPT-3 to the time of GPT-2. We built an app called Peppertype, which was essentially Jarvis AI or Copy AI competitive, scaled to about 1 million users across the world. And this was early 2021. This is all before ChatGPT came out, and GPT-3 was in private beta. We started building that app, and there were a lot of learnings over the next 2 years with the advent of ChatGPT, how things changed. And to this day, where every other week or month there are new models. These are faster, more capable, more secure, basically maybe smaller in size, cheaper to train, easier to install. And every day there are new techniques. We've heard of RAG. RAG became popular, then RAG with graph data, which is becoming popular. Somebody I heard was talking about RAG for agentic workflows. Agents and all are becoming popular. There are new ways of doing things, right? So how do you essentially build your architecture or build your application which is forward compatible? You don't end up rewriting all of your application logic, business logic just because you want to try a new model, or you want to try a new embeddings, or you want to try a new technique. Right? We're going to cover all of these points in this talk. And eventually, once we figure out, okay, this is how, the goal, end goal is that before you push your application, you are confident, right? It's going to work. So far, we've seen that it's extremely easy to do a POC, right? You can build an app over a weekend. We're all engineers. We know how to connect an API, and there's a extremely simple APIs that we have from maybe 10 providers now. They scale well. We don't have to really do anything. It's an API. You write a quick prompt. There are a bunch of prompt libraries available. You can write a simple prompt yourself. But from POC to production is a long journey. How do you get that confidence? So before 2021, if you were to do anything ML, it's a long checklist. You first find the data, you clean the data, you prepare, test, validate the data sets. Then you prepare a training pipeline, you test the new model, beta test, go live. And after all of this, if you have gotten 20%, and probably you spend if you're in a larger company, you spend 9 to 12 months doing this. And after that, you see a 20% increase, and that's the best day of your life. Right? This is before 21. Today, or when the ChatGPT came, you write 10 prompts, connect to OpenAI, go live. Right? And it improves significantly. You're not fighting anymore. Hey, my model can only understand a certain language because although I've trained it on the actionable data, it doesn't understand NLP. These were two very separate problems. Not even thinking about NLP as a problem. We know if you're going to use one of the LLMs, they understand English, they understand probably other languages as well. Right? So there's a stark difference how you do AI ML application development before and after generative AI. How many of you have seen this message? Nice. Right. So this is your problem one. It has become easier, but there are a lot of challenges. We are talking about those challenges from POC production. You use an API, it would work fine. You would have certain rate limits, but it's not production ready. It won't have the scale, or it won't have the rate limits or reporters that you need to probably need in your production systems. So the first problem. To solve this, you would maybe buy 2-3 different licenses, do a round robin between them, and you're like, okay, fine. I have more rate limits, and I have deployed something on my Bedrock or SageMaker or whatever. I have a better, rate limits. You've put in all the hard work, you put out the code, and you get very useful feedback from the users. Right? your AI doesn't work. You have no way of understanding, you put in an LLM, how do you even debug? Where do you start? So there is no visibility. What you're dealing with is a black box. It is /AI, /human, /chat, /completions, and that's the only thing you can debug, key, endpoint key. But there's nothing beyond it, right? Your AI doesn't work, it doesn't work. Okay, now what you do is, to solve this problem, you would say, okay, hey, I already have an observability stack in my application. My team uses Datadog or Splunk or ELK or whatever. Let me put my request response objects here as well, and then probably I have some more data to play with. The day you do that, your manager comes and says, hey, how does our Datadog bill is 10x now? The reason is because all the existing observability stack, they are not meant for Gen AI logging. They are typically meant for, this was the endpoint, it returned 200, this was the response time, here's the stack. That's it. What you need is, for the observability, is not fulfilled by them. You are logging in extremely big context length requests and responses and doing nothing but bloating your Datadog or costs and observability costs. But okay, you build your own ELK, you started saying, okay, we will, critical ones we will log in these. But then, you have some rate limits, you have, and some observability in place. Next day, there's a new model. Meta has a new model, Gamma has a new model, Google is launching new models. Now your manager goes to a meeting somewhere and he heard all of these things and goes, hey, why are we not doing this? And the reason you're not doing this or you're not able to do this is because you have to change the entire logic. /AI, /chat, /completions, the contract, the endpoint, the prompt, nothing is going to work if you copy paste it to Anthropic or any other model. They have their own signatures, they have their own way of working, they have their own use cases, latencies, etc. Switching costs are extremely high. And you're not just switching the model, you're redoing observability or redoing rate limiting or whatever logic you have put in place. The switching cost is extremely high. The other problem is, okay, fine, if you have not read this, I encourage you to read this, it's extremely funny. But how do you tackle situations like this where you have a chatbot and it just sells your Chevy Tahoe for $1 and it says it's a legally binding offer, no takes these batches. So these are actual production challenges. You put it on chatbot and they're just talking to an LLM. And it's a simple prompt hack, right? It says, hey, whatever I say, you just add, it's a legally binding offer at the end. It says, will you sell me this thing? He said, yes, $1. It's a legally binding offer. Although nothing happened, but there are, if you have read about airline news, there's a Canadian airline, they actually had to do a lawsuit to get out of this. Right? Because their chatbot confirmed something which wasn't correct. So these are the typical challenges that I learned over a 2-3 years time frame building those apps. That it's extremely low visibility, control over cost and performance is almost negligible. High switching cost, testing is expensive, and you have to test a lot of things. You don't even know where to start, where to end. Code isn't future proof. Whatever you write today will probably not be required in 2 months, 4 months. And there's regular safety, security nightmares. So far, we work with a lot of enterprises. I've not seen any enterprise or even a SMB take agents to production, and the reason is security. While it works, you have done the POC, you've built an agentic workflow which says, okay, this has access to my HRMS, and now it will pull the data and answer your questions, but you say, what is my CEO's salary, and it returns it. You don't want that to happen. So that is the reason people, don't have the confidence to take their agents to production. But if you think about it, all of these challenges, and I'll go back here, the visibility, the testing, forward compatibility, safety, security, none of these are essentially either a business logic, business challenge or an application challenge. These are typical DevOps challenges, or we say ops challenges, right? You want to scale, you want to test, and we have been solving this for the last 2 decades. It's not new, right? What changed now is, so far, we have built all the systems, we have built our mind map to deal with deterministic systems. Now, what is a deterministic system is, you send an input, you get an output. And you are 100% sure for this input, this will be the output. It won't change. Whereas now when we deal with LLMs or generative AI, we are dealing in the probabilistic world, wherein for the same input, the output could vary, and you have no control over that. Right? So, yeah, we said, okay, these are all ops challenges, and there has to be a better way to solve this. Currently, and the solution that we have is something called a gateway, and I'll just show that in the next slide. But typically, what it looks like is you have an AI application, you have an AI model, you connect. Right? This is fairly simple. Probably that AI application also has a vector database, but model-wise, you have an API of the model, maybe self-hosted, Bedrock, whatever. You go from this to this. Now, what essentially this is, we put a layer of AI gateway in between. This layer gives you observability, of course. It gives you the routing capabilities. What is routing capabilities? How many of you worked with API gateways before? Nginx or things like that? Awesome. So if you are familiar with this, so you have the right routing capabilities. Think of your LLMs as simple target groups. You define your routing logic either in the application or in the gateway itself. So that's important. There you have guardrails. Guardrails are validating the input and output. That if let's say you're talking to a chatbot and you don't want your chatbot, your end user to put in their PII when they are chatting. Right? They should not put in their phone numbers, emails, because that's against possibly your company's GDPR policy. So you need those guardrails both on the input side and on the output side of the LLM. You need a way to manage the prompts. You don't want, if you're, probably you have a separate team who's working on prompt engineer, probably yourself, you're writing prompts yourself. You don't want, if you just want to add, let's say, an example or a few lines or few words in the prompt, you don't want to take it through the entire SDLC lifecycle again. You don't want it to take 2 weeks. You want, okay, I want to make a small change in my prompt. I should be able to quickly test it and push it out. And then, of course, all the security measurements that we need, WAF, firewalls, typical API, gateway security. Right? So this is what we've built called AI Gateway, and this gives you control, visibility, and future-proof. Right? Now, what we're going to do is we're going to just zoom into this gateway, look at all the different components, how you can build them, and we can keep it more interactive. Instead of me just having a long monologue, let's keep it interactive. Just raise your hand if you have any questions. But we'll talk a little bit on the architecture side. Just before that, the gateway that we have built is open source. We have partnered with Nginx, so their AI gateway, Nginx plus 40 works together to build API plus AI gateway. You can find it on our GitHub, use it. It runs as a service, it's not a library. Just like Nginx, it's not a library, it's a service. You deploy this as a service, run it on a server. Now, moving ahead, this is a QR code if you want to scan. This will take you to the gateway URL. Camera here. This is what the gateway looks like, and I know it might be too small. We will zoom in into these pieces over the next slides. But give an overview. I'm not interrupting anybody's view, right? So what we have is we have a business logic on the extreme left hand. This business logic is essentially your generative AI service. This could be any service. Let's take an example of the service we heard in the previous talk. Excellent example, excellent use case. We want to build our own personal assistant. So that's a AI service. If you're building a personal assistant, you need to give the assistant all the data it needs, which is essentially your context manager. Let's say this connects to your Mongo or wherever your data stores are. You possibly find any vector. You have a vault for API keys and you have some prompts within there which you are versioning and you're managing the prompts. All of this logic is, let's say, this is your application. This has so far nothing to do with generative AI or interaction with the AI. What you do is you put a layer of AI gateway in between. We've already talked about what is AI gateway, what does it do. you do the inference. So the way this diagram is, you can follow the green arrows. The green arrows take you like while you're making the request. The blue arrows are response coming in from LLMs to your application. Yellow is the observability and brown is the training diagram. So try to divide to make it simpler. Try to divide the entire architecture into 5 different blocks. And let's look at the first block, the green part, wherein a call is being made to the LLM. So what's happening is, okay, you know what's your business logic. You make a call, and you see the AI gateway. The first part in the AI gateway you see is it's a unified gateway. What essentially a unified gateway means is the gateway provides you a unified API to connect to any LLM. What that means is, today you're using OpenAI, you want to use Llama, Mistral, Anthropic, anything whatsoever. The API remains the same. It's a unified API for us in our open source version. It's the OpenAI standard. Now, OpenAI may call it file, Anthropic may call it document, whatever. The transformation layer is written inside the gateway. So you just tell the gateway, hey, this is my contract, which is OpenAI compliant, but I want to make call to Anthropic. So the gateway understands, okay, I'm going to make this call to Anthropic. The contract has to be transformed into the Anthropic format. So it becomes a unified gateway. It understands only one format. We've chosen to use OpenAI format. So real time, your unified gateway does the request transformation. You define your rules. You want to load balance your calls across. Now, very, very interesting thing, because you have a unified gateway. Now you can do a load balance not just between OpenAI models. You can do a load balance between Anthropic and Llama, Bedrock, and Azure, OpenAI, anything to anything, right? Because it's the same contract you are sending, and the gateway is taking care of transformations. So you don't have to worry about installing multiple SDKs, installing multiple keys, all of those in your logic. You just tell, hey, I want to do a load balance. You can configure your load balance tools. You want to do a fallback, make a call to OpenAI 3.5. If it fails, then fall back to Llama, host it. If that fails, fall back to my own hosted Llama, which is probably quantized out, but you can configure with your rules. You can do a mixture of load balance and fallbacks. You have 2 load balance targets. Each load balance target has fallbacks configured. The next part is gateway has inbuilt caching. Just like if you have caching at the API level, same way we provide caching. But very interestingly, in deterministic world, we said every input has the same output. Here, every similar input can have the same output. What's the weather today? What is the weather? How's the weather like? These are all same questions. You don't need to send them to LLMs every time. You can cache the result and find the contextual similarity. If they are semantically similar, you can return from cache. So we have that cache store built in. It's part of the gateway. And we have seen up to 60% cache hit, especially for Q&A and RAG-based applications, because typically you're asking the same questions. Please go ahead.
Sorry, when you say you cache it, right, it's a language, it's a natural language, right? So how do you map that unit was the same database, or you just get some keywords out of it?
No, it's typically it's not keyword based. It's proper. You find the cosine similarity. You use word vector database. Do the embeddings. Find the cosine similarity between the embeddings. Do the federation of metadata, and then that's how you find the similarity.
Based on some stage.
Yes. So there's a threshold. Of course, you can configure your very high. We typically keep it like 97% match. Then you should return otherwise. But it's not keyword, this is a proper semantic similarity. You have automatic retries, you can configure if it fails to an exponential fallback or whatever. Okay, once you've done, the gateway would essentially, but once you have the request, gateway would figure out, okay, at this point in time, after load balancing, fallbacking, whatever, I need to make a call with these parameters, these properties to the LLM. So it comes to the inference block. First thing you do is, you do your evaluations. You do a PII scrubbing, you do your firewalls, rate limits, whatever. You know the input is now safe to be forwarded to the LLM. And then you essentially forward it to either cloud hosted, self-hosted, fine-tuned, wherever. And how do you know where it's going to hit? You've configured that endpoint or target group in the AI gateway. Any questions in the request flow?
So you asked that, there should be a filter. For example, if somebody is asking what is salary of a CEO, that should not be done.
Yeah.
Where the filtering is happening, or where that part is kept there, this amount of questions.
There was this guard today, it's not.
Correct. So this block is essentially the guardrail. So you would put your rules either here. But see, when you're dealing with Gen AI, a lot of these things can be in different places. There will be security logic in your business as well. Your agent would figure out, okay, you're asking to start with the CEO, who is the CEO, this is the CEO, what is the user ID of the CEO, this is the user ID of the CEO, your RBAC will fail. Either it could be at that level, it could be in the gateway level that you have different blocks if you're executing agents, which tokens has permission to execute which agents, and then of course you have the evals. You can configure rules that you cannot ask for a role, a salary by a role, you can say what is my salary. If you are asking by some role, then probably you just return the document of whatever your brackets are or whatever, if that's public. Otherwise, you just say, okay, it's not, you can't handle the data. But it could be multiple layers.
So since you have multiple LLM models, is there some sort of a decision service to pick or rank the response from different models? And
that's again your evaluation scores. If you want to evaluate a model, you can use the gateway to hit multiple LLMs. Because it's simpler, you don't have to reconfigure or download multiple SDKs or whatever. And then you look at the evaluation scores.
Is it anything different from the AWS API gateway?
It's meant for LLMs, that's the only difference.
Yeah, the LLM doesn't matter, right? It's just the content goes inside.
Correct. So, if you
what exactly is the different, by the way? Even API gateway is just going some.
It's just a router. API gateway is technically a router.
It can do a lot of things.
It can do a lot of things, but two differences. Primarily, one is it's agnostic to the platform. Like I said, when you're doing your routing, it can be between Gemini and Azure and whatever.
Yeah, also you can do it there.
Yeah, if your endpoints are public, of course you can do. If your endpoints for LLMs are public.
I'm just trying to see what is the uniqueness of it.
So you have, when you are configuring your load balancing in your API gateway, you can't do it based on your evaluation score, and that would come in the next step when the response comes. But what you are essentially doing is, in the API gateway, typically all your decisions are based on request. Look at the request, decide where to forward it. Here, it could look different based on is it a semantically cached version or not? Is it the evals have, what is the output of the eval score? What is the prompt? So what you can do is configure the gateway, directly connect to your prompt management systems. You just pass the prompt ID or the prompt template ID. So there are a lot of, so fundamentally you are absolutely right, it's the same thing. There's a lot of common things between an AI gateway and an API gateway. There's AI gateway is just an extension of API gateway, specifically meant for evaluations, routing, essentially in all those 4 or 5 areas. It's just an extension.
Applying a domain knowledge.
Sorry?
You're applying a domain knowledge for AI, right?
Correct.
That's the phenomenon. Okay.
Yeah, so curious in the smart cache. So those questions are validated if it is asked with similar ones or not. So where are you maintaining what is the retention period for
That can be configured. Whatever your TTL, like you put a TTL in your Redis or whatever, you can configure.
Okay, so what if I just configure it, say, living for 3 months of time? So obviously, in 3 months there will be a lot of questions. So thinking about the scale, a lot of questions being stored. So where exactly those questions are stored? Is it all on the cache or in the storage?
Obviously in a storage. I mean, nothing is stored on memory. It will connect to a Redis instance or some instance.
So just curious, like you want to talk about what data storage it is used
So
for.
our deployments are on Cloudflare. We use edge computing. So on Cloudflare we use Cloudflare KV store. We use the durable objects for different use cases. When we do on-prem deployments, we prefer using this.
Okay, thank you.
One, when we do back and forth communication like a conversation, if you have some sort of gateway in between, let's say the timeout is happening, how do you maintain the continuity of the conversation?
So gateway doesn't care of the continuity as long as it's a simple API call. So every call is a different request.
So it is handled somewhere else?
Like for example, there's a timeout happening by a certain LLM, or there's a timeout happening by a certain LLM. So what happens in that scenario? Is the gateway enable me to still maintain the state of the conversation?
Gateway stateless.
I don't mean the state in terms of the theoretical aspect of the state. The state of the conversation isn't the.
That would be maintained by our application. Not on the gateway. That's not on the gateway.
Second, when we have different LLMs working together, prompts are not always the same. Like a prompt will not work the same way with a different LLM. So if I'm calling back and I'm switching LLMs in the gateway, does the gateway gives me option to configure the prompts or redirect to a different prompt?
Yes.
Thank you.
So you can have, if you're using our managed prompt services, you can just pass a different prompt ID, or there are ways to not just the prompt but all the hyperparameters of the model. You can override if you're in case of loadback and instead of fallbacks. Moving on, now we're looking at the response. So your response comes first, they go through your evaluations. So you can have a deterministic guardrail, or you can have like a model-driven guardrails. Deterministic guardrail is anything which returns a Boolean output. Think of like contains words, does not contain, is a CSV, is a JSON, whatever. Anything which is very logical and has a 0 and 1 output. So you can configure those rules here. Then you can configure your model-built evaluations or typical guardrails, as we would say, which is, think of like, is it toxic? Okay. So that's never a 0 and 1, it's a percentage. And it's probably used another model is used to evaluate that. So you can configure those rules, and in the gateway, this is something you can configure on the gateway side, that if any of the guardrail scores fails, do I want to retry the request, and if I retry with what configuration, or I want to just return the output, or I want to get the output, don't do a retry, just log the output, but to the end user return error. Because that's something you can decide, that how bad an output is bad enough to be shown to the user. So you can configure those rules. Again, request is sent to the gateway. This time, a response transformation will happen. You send the request to OpenAI, output is in OpenAI, that's fine. Your application is expecting it in the OpenAI format. So if you had sent it to Anthropic, at the time of sending it, we did the request transformation, we did compliant with Anthropic. Now Anthropic has returned the response, of course it's going to be in Anthropic format. So now you have to transform it again to make it in the OpenAI format. Because that is the end format your application is expecting.
So currently, what is your overhead on transformation?
Sorry?
What is the overhead on your transformation?
Hardly anything, it's just key mapping. The entire gateway takes less than 1 ms.
No overhead? Every transformation takes certain overhead, right?
I mean, technically you are very right. Yes, every transformation would take an overhead, absolutely correct. If you think it in the terms of an LLM call, which itself is taking 5 seconds, 10 seconds, adding maybe 10 ms doesn't count it. Like, relatively, it's negligible.
Yeah.
Technically, it's...
But you need to think in scale also, right? In millions of transactions, billions of transactions.
Yeah. We have benchmark the gateway. It processes 10,000 RPS on two medium machines with the latency of the gateway latency of 1 ms minus the network.
Because I see you are doing a lot of things, so...
See, a lot of things is supported. You don't have to do a lot of... See, for an example, you say you want to do an evaluation which is done by a model. That's not gateway's latency, right? I mean, gateway's latency, I would say, is the time it takes to do the routing. That is the gateway's latency, routing and transformations, right? Now, if you say, hey, I want to run 10 things before I send to LLM, 20 things when the response comes, that's not technically a gateway's latency. That's part of your workflow, which is enabled on the gateway, right? So yes, we do a lot of these things, but when I say the core gateway latency comes from load balancing and fallbacks, these things, this is less than 1 ms. Like I said, we've benchmarked this gateway running on two medium machines, 10,000 RPS.
So these guardrails, everything runs on where? It's not in a gateway?
So we have all of these things they are part of, they think of these like as plugins. So you
Yeah,
can install
eventually-
different.
Eventually supposed to be run somewhere, right? Is it part of the API gateway or is it part of the LLM?
It's not part of either of them. These are functions. This function see. One thing is I cannot write every evaluation. Your evaluation could be a lambda function. Your own data sources, whatever you do, this could be within your. If it's a logical rule, you just want to do something, you can write in the
So
gateway.
you're saying you write in your lambda.
You write wherever. The gateway needs a connection to run that function. Either that, or if you want to run it on the gateway level itself, that's also supported.
No, I'm asking this question because you're actually providing a runtime, right? So not like a SDK.
You can configure the guardrails to be synchronous or asynchronous.
No, when you said you're not providing an SDK, you're actually providing a runtime, which is a service you're providing.
Yes.
So I had under the impression your service is actually having it.
So service has the capability to execute those functions. These functions could be written inside the gateway, yes. These functions could be in any other network which can be accessed over HTTP as a REST endpoint. Can be configured. These could be sync, async. You say, hey, run the guardrails, but I don't want them to be blocking. If I want them to be non-blocking, just do the observability, just log the outputs. If you want that, hey, let the guardrail run, see the output, and then do a retry or take a decision, then they will block. These are all the, I would say, configurations that you can pass in the gateway.
I'm passing.
One question.
Yeah.
I'm not aware of guardrails. At the same time, my question is two things. Let's say guardrails, what does it, is it guardrails, is it rule-based decision making, something like that?
So guardrail in the simplest terms is rules to check the input and output of LLM. Right? Now, guardrails could be of typically two types. One, which is a logical function which returns a boolean. Examples are the output contains certain words, does not. For example, Flipkart using in LLM, they said, write a marketing copy for this product. They would typically put a guardrail saying the output should not contain Alibaba, words like Amazon, Alibaba. Right? This is very logical for them. Their website, they can't use these words. It could be on the output length, format of the document, anything, which is assuming 0 and 1. Then you can have a probabilistic checks, which is all of your toxic, abuse, violence, anything that you can think of, which is always a percentage. So, and that is not a simple function, that's a model grading the output. So all the typical guardrail systems that we see, all the companies that are startups that are doing guardrails, they are all using another model saying, hey, this was the input, this was the output, these were my parameters, tell me how good or bad the response was. So this could be another GPT 3.5 prompt.
So using that probability outcomes, you are going to determine the...
Yeah, so using the output scores, you can determine in the gateway what to do.
Okay.
Cool. So we made the request, we got the response. Now what so the gateway does is it uploads it to your observability stack. This observability is very interesting because now you have the request, you have the response, you also have the quality of the response through your guardrail scores, because gateway has that data as well. Plus you can have other data sources. For example, you have on your end application, you have built a thumbs up, thumbs down, star rating systems or whatever. You can capture those metrics, send all of them to your log processor, put in your tokenizers, calculate the cost. If you want to do any data masking, do that. Put them directly in storage. The good part about this is you don't need to do any transformations, cleanup later, because all of them are in a single format. So you know exactly what is the format, where was my response, what was the output, and how good or bad it was. Based on you build your alerting and monitoring. If let's say suddenly an LLM starts to degrade, you will start to see some errors that suddenly some application somewhere is returning bad responses, or users are not liking it, or maybe the latencies are extremely high. You can configure those rules. Typically, like we encourage to use not your ALK and that stack, but store these outputs as documents. If you have a self-managed Mongo storage is cheap, put there, or put use as or any blob storage for these documents.
How do you determine like whether the user is liking the, you mentioned like a user not liking
Guardrails plus code.
Okay.
So your guardrail score would go down, right?
Like the response already went to the user, right? Then if they feedback, if
That is if your thumbs up, thumbs down, star rating is configured on your application. Because that is your other data sources here, outside of the game.
okay, so for that, I need to pass on external for external API.
Yes.
Consider this is the issue.
So that's, in our system, that's a API of the gateway itself. If you're building it yourself forward, then you can have that data just attached to that log ID. Okay, so from your observability stack, you are taking it to your training stack. This has your training data, validation data. You can bifurcate these data sets probably on, do some. Typically, people use 70-30 or 80-20. 80% of data is used for training, 20% is used to then validate if the fine tune is good enough or not by checking this thing, the similarity between the good scores and bad scores. And why it is very easy now to do training for use, because again there is no data cleaning required. You would simply put guardrails plus score greater than your threshold. You have the logs which needs to be fine-tuned. The model needs to be fine-tuned on. You also have you can attach metadata, etc. So for this use case, these are my logs which were found good. I just take that data and fine-tune it. Create your fine-tune. This could be also done in your fine-tuning service, and then again gets attached to the LLM. Becomes a part of the gateway. Now, if I just go back to this diagram, imagine you have a fine-tune. You have your fine-tunes here. Now, in load balance, what you can do is gateway can also allow you to do A/B testing. You have created a new fine-tune. How do you get the confidence that it's going to work better? You do a load balance 5%, 95%. 95% can go to your current model, 5% can be routed to a new fine-tune. Check the output score, evaluation scores. Now you know it's performing better or not. Based on that, you can remove that fine-tune from the system or start putting in more traffic to that fine-tune one. We have 9 more minutes. So we've seen how the gateway works for all the components, and again coming back to this slide, this is what you achieve. We call it the AI gateway pattern, and the AI gateway with all of its capabilities. And so far, we offer managed services as well. We process about 450 billion tokens. Currently, we process 20 million LLM calls passing through the gateway per day. Some of our customers, Postman is, if anybody has used Postbot. So Postman has an agent, like an AI tool called Postbot, wherein the Postbot will, you give it an API, it will write the documentation and test cases and everything else. So all the 20 million devs of Postman using Postbot is all built on OT. And that's my time, and thank you very much. We have about 10 minutes. We can take questions.
On the evals part, are these more evaluations on the functional perspective? So the evaluation is more on the functional perspective as to how the responses are coming, or is it like a more generic framework where you can put in some code and figure out? So essentially trying to understand, do you have a suggested calculation, scores for capturing the evals, and not just limited to models, maybe around even prompts, etc.
You're asking from the code perspective or in a general perspective, what should be the guardrails?
Both probably.
So generally, the guardrails are, there is no set protocol as such. You put the guardrails on the things which are most critical to you. You probably don't have guardrails for 100% of your services or 100% of your use cases. You configure guardrails on certain use cases, right? It is possible, and I've seen this in a lot of production applications. You're using a smaller model like a Llama or a Mistral or 3.5 for actually doing the inference, but you're using a GPT-4 to do the guardrail. Because while getting the output is okay, is it correct or not is extremely critical for you. So technically here, test cases are expensive than your application, and slower. but it is very common right now in production. So again, answering it could be anything. What is more critical to you? Which model you should use for guardrails? Advanced use cases, you have a fine-tuned model for guardrails. So eventually you're using a DPD 3.5 or 4, whatever, but you keep making it, keep fine-tuning it so that it does a better job at guardrailing. I think that's all right. From the code key perspective, we realized early on, of course, that each use case is unique. The use cases or applications that you're building might be very different than what you're building. I can't necessarily think of all of those guardrails and put them in as plugins. What we've done is we've seen like some top 20, 30 or 50 maybe use cases that are very common. All of those are available out of the box to be used on code key. Other than that, we've created a framework wherein you could use any guardrail. Guardrails written by you. You are managing, like I was saying, maybe it's a lambda function, as long as it's a an HTTP call or something that the gateway can connect to. Then we are also partnering with about 5-6 very common, popular guardrail companies. So they have a native integration in the code key AI gateway. If you're using their guardrails, you would be able to execute them on code.
Thank you. My question is very generic, like how did this whole company idea occur to you?
Like I said here, last been building GenAI applications for 4 years since DPD2, and over the course of scaling an application, where every day these problems were there, and we realized that hey, this was around and we've been building applications since early 2020. So when ChatGPT came out, one thing was common is that AI is going to be a commodity now. Right? Every tool, digital product will use AI eventually in some form or fashion. And if everybody is using AI, everybody needs to do this tooling. And that's where the idea came from, that whatever hacky code, tooling, retool applications, lambda functions, random things we had to do just to support our applications that can be packaged. Those are all offset in this, and can be packaged as a dev tool as such. Of course, over the course we have positioned it better slightly, like we call it the AI gateway pattern, etc. But that was the initial idea.
What is the system requirements to be put into production for this API gateway? Standalone.
It's a Docker. We have the Helm charts. You can put it on ECS.
Does it require any GPU kind of?
It's a
normal.
It doesn't do any analytics. It needs a log store. It needs an analytics store. It needs a cache store. It needs a vector store if you want to do caching, cache store, whatever like features you want to use. If it requires a data store, you configure that. If you're doing an on-prem deployment, if you're using cloud, like if you just go to port KI sign up, you don't have to do anything. You just make it.
So how is the routing happening between the LLM presence and multiple LLMs?
Think of these like target groups. You have defined them in the gateway. That I want this request to be forwarded to this group.
So is it based on this score or like?
It's not based on score. It's determined by the business application. This application wants to use these models in this order with this load balance.
So that is defined already.
It's already defined directly, and then the second layer, like fallbacks, is defined by the output. If you want to configure that, if the output was this bad or that bad, or 500 came from OpenAI or rate limit happened, then fallback on these conditions, fallback to this model. It's all. It's like a JSON config that you pass in the gateway.
Yeah. So my question is, this is not a technical question, more so on the business side. You might choose not to answer it, but still. So I saw your clients. I mean, like at the end, which you showed, like Postman and all. So usually this is this is basically a B2B business. What I've seen here. So I mean, do you guys have any plans? I mean, like again, as I said, it's a confidential question. Sorry. to actually, I mean, make certain, so the AI application that, those are your vendors, I mean, those are your clients basically who connect to your AI gateway. So, I mean, for creating some kind of B2C application, of course you have your AI gateway and everything it does, it, kind of routes requests to the various LLMs. So many, do you guys have plans to make something on that B2C front? I mean, let's say like in the morning we were actually seeing about this, GitLab, that particular extension in VS Code, where you type in, generate codes, entity classes, and so on and so forth. I mean, do you guys have any plans on that which maybe a normal developer can use?
Okay, so I mean, the application has a developer fee. This thing, you can sign up, you can use it for free for up to 10,000 requests a month, 10,000 LLM calls a month. You can have access to all the features. So, I mean, as a developer, individual developer, you are writing something, trying out something, you can sign up and use it. There is no restriction as such. I mean, it's a dev tool. I obviously make money by sending it to businesses. I don't make money or want to make money from individual developers. So there's a free account, free tier. Developers can use that.
So I have a question. So the configuration that you provide, that is through port key control panel. That's from where we provide all the configuration for the API gateway.
For the port key managed, yes. Not on the open source part. That's not part of open source. The UI and everything. Open source is the gateway with routing and other stuff. If you want a UI and posted gateway and everything, that's where the UI comes. Where it gives you a lot more analytics and observability and a bunch of stuff.
I have a second question, and this is with respect to when you were making the request. That is, when the request was going in, there was some kind of a sensitized data removal kind of a thing.
Yeah.
So what kind of data does form, do you remove in that? Do we remove in
Again, configured to our use case. For example, a chatbot, you don't want to accept emails, phone numbers, addresses, whatever. You want to redact them. Names you want to redact, anything like that.
any PII kind of?
Any PII.
So what is the frequency you fine-tune the models if it's in production, right?
We don't, so we have the capability, we are a platform, like we're not on the application, like we don't provide any application as such. Think of it like a very, very mini, like AWS in itself. You would come and configure when do you want to fine tune, how do you want to fine tune, with which data. And we have this concept of continuous fine tuning. You can configure, automatically update my fine tune every 10th day or after 10,000 requests have come in with this score of greater than this. Then we would automatically do it, but again this is all configured by the customer or by the developer.
Yeah, I have a question related to billing. Let's say I have an application, it's a basic application which can be, my requirements can be fulfilled by any normal LLMs. So can I get a breakdown of how much I've spent on this LLM costing? And
all of that, like to each request level, what was the token count in request, what was the tokens used in response, how much it costed you, who was the model, who was the user who made it, you want to attach any business metrics to it, all of that analytics is available.
And I can, comparing notes I can get, like if, same thing if I would have got it from other models.
Yes. So we currently support about 30 plus providers, which is about 225 odd models, which are supported with transformations and everything.
I get a notification that instead of using this particular model, if you would have used the other model.
That intelligence is not built yet. You would have to come and look at the metrics yourself. And no automation isn't there yet. We plan to do it. That you could have, say, let's say we're using a GPT-4 for a very, very simple use case, then the gateway or the system can tell you, hey, if you were to use a GPT-3 5 turbo instead of 4, you would have saved 10x and get it faster or something. That's something we plan to build, but right now it's not there. Right now you will have the data, you can come and look at it yourself.
What is the tech stack used? Is there any slide or
So the gateway is written in TypeScript.
just
Okay, so maybe we'll take just last question.
See, looking at your product, let's say Portkey, how much outcome or professional? Is it more on analytics you are working on, or is it more on evaluation? Let's take it.
So we have three main pillars:
Ah,
the AI gateway, observability, and governance.
right.
So we have a lot of depth in these three. So you could see, I think there's analytics, logs, model configuration. Models is essentially your prompt management systems. Configs are your gateway configs. We have the concept of virtual keys. We can discuss this of course later. Settings and evals is your governance. So these are all the things that, all of it is taken care of by Portkey.
But still, my question would be single. I want to rely upon your product. Maybe what is
USP.
yeah, maybe something like that.
USP compared to big players.
No, suppose, not comparing. Within your own model, let's say analytics, or I'm a third party where I want to use this your infrastructure. No, now I need to evaluate whether you are good at analytics or model or evals. So that way, how do you rate yourself in these three? Or observability as well?
The core concept is that you start with the gateway. Right? First thing is the gateway. Like we talked about the architecture, right? Gateway is the first.
Right. No.
We don't offer just use our observability. We are not Datadog. We are not competing with Datadog, or we are not competing with any of the storage or observability stuff. We are not saying we are the prompt management system that you use my prompt. There are 10 others. Our core product is gateway with guardrails. You get observability as a byproduct. There is prompt management that you can choose to do here, or you can choose to not use prompt management but still use the gateway. So we don't, like if you were to compare Portkey, you wouldn't compare it separately, all of these components with different disciplines. You would compare this with an LLM ops stack. Which an LLM ops stack, if I were to mention a few, with gateway support, there's only one called Arise, Arise AI, which has an AI gateway with obviously a lot of overlap, something minus, something plus, of course.
Something like maybe extension of AI applications, where maybe it gives a platform to do integration, especially AI API. Gateway API is for most of them used for integrations. Am I right? So there it might be this more feasibility with the use case perspective. That's what I'm trying to say for B2B applications.
So,
am I right?
I'm sorry.
Let's say I'm doing B2B business. You have my company and your company. In that perspective, I want to have it, I'm going to use your, maybe this, one of the features which you had, API gateway.
Yeah.
So even we have our interfaces, we going to interact with you to establish some business, maybe for analytics perspective, or maybe evaluation perspective, use case perspective. That's a couple of use cases I chose. Maybe that's how it maybe is feasible.
Okay. So you're building an application, you have done POCs, you have used models, you know, okay, this POC works, but our focus, if I were to say, is productionizing. Before you go to production, you need these things in place. You need control, visibility, and future proof. So that's when you would come and put Portkey. I say it very often is you don't need Portkey on day one. When you're starting to write an application, doing a POC, you don't need all this. Like when you write a new application, you just have a server running in your local, you don't have 10 other things. You don't have an API gateway and this, the firewalls and a bunch of these things. Portkey is only focused on productionizing your AI. You need, when you're in production, you need a lot of compliances, you need security, you need more control, you need more visibility. That's where Portkey comes in.
Okay, so we have come to the end of the talk, basically. So thank you so much, Ayush.
Thank you.